Okay, you hear me? Yeah, I think it's perfect. So thank you so much to Piotr for invitation. I am a little bit afraid of talking to you. First of all, because I haven't been presenting in English for a while. Second, I am not really a software developer, but I'm riding on this wave of AI and agentic development. So I kind of wanted to, we thought together with Piotr that maybe it would be also interesting to show how somebody like me that doesn't have a software development background has been using AI tools for last around 18 months to build something that hopefully works. It worked quite well today, so I'm quite happy with that. And I wanted to kind of give you a little bit of my story with this agentic development and some funny things I did and some things that I've learned, and hopefully you'll enjoy that. So just very briefly about me. Yeah, there's a little bit of nudity to start with. Like I have a movement practice and coaching background. For last 10 years, like I've been really mostly interested in physical practice and physical education, and really building up skills and everything that is related to human movement and human body. No need to plus. Just some kind of visuals so we can get a bit of understanding. Like I am really interested in how can we make movement development fun. And I'm interested in about like a human movement development framework. Like, you know, in software development, we have frameworks, and I love this kind of structured thinking. And I wish to apply the same kind of thinking to physical development. This is my background, but I had which I feel was like a very important side quests, which were FPV drones, and this is how I got into hardware. You know, how building hardware, like with your fingers, with your soldering, and also flashing the firmware with assistance of the early AI. And some software for flashing, pit tuning, just crashing, rebuilding, constantly working with your hands and trying to make something that uses electricity work, you know. And I really enjoyed that, and I think that was something very empowering for me. Well, I thought that I can actually build a physical thing that is also somehow electrical, digital, and I can make it work. So I'm doing masters in strength and conditioning right now near London in St. Mary University. And when I was there, I learned so much about the things I didn't know, so much about how we can quantify human motion, how we can put human motion into numbers. But the problem was that to get these numbers, you would need really expensive technology. Like, if you go into biomechanics lab and you're looking at the equipment, you suddenly see $200,000 force plates, €1 million or £1 million motion capture system. This is not something that you can afford, obviously. And I was like asking myself, how can I get access to this sort of technology, this sort of tools? And just start to using them to also learn about human motion, but through signal, through data. So not only the subjective and the playful and the kind of variable approach to motor development, but also the more scientific, the more data-driven approaches to the human body. So this is a very old recording of a guy doing a jump in slow motion. So what you've seen during our competition, it's the force trace aligned with the video, and you can see how the forces are changing, right? How they are dropping first during the ascent, and how now they are rising because he's braking, he's slowing down. Now he's propulsing. The force keeps rising a bit until the flight, the force drops down, right? We have the flight time, quite long. And one, okay, I'll skip this. But yeah, let's wait. And the braking phase, right? So as he's touching, the forces rise up really, really rapidly. And this is actually funny because most of us, when we think about building strength, we think about moving things around, moving up, moving forward. But actually, when we are decelerating, when we are braking, majority of the highest forces appear. Just as a kind of side note. But I was like, wow, this is so interesting. Like we can actually start to reason about human motion through this signal. I want to do this. I want to learn more. But the problem was that I couldn't afford this equipment, so I decided, okay, I'm just gonna build it. How hard can this be? And it turns out that it was hard. I started with like Arduino, with some analog to digital converter from AliExpress, with some basic Arduino code and serial monitor for reading data. I will never forget the feeling that I had when I saw these numbers appearing when I was pressing the sensor. It was just like one of the best moments in my life. And I made it work. I made some like a one file Xcode project with like with a force trace where I could just stream via Bluetooth the force trace with a single sensor. I think it should appear somewhere here. Oh, this S-shaped load sensor. Never mind. It was just a single sensor. And this was like the initial step. I was like, okay, I'm gonna build it. And this was already, this was early, this was when ChatGPT and I think I was using ChatGPT and Gemini then, which is just, you know, like, do this for me. Do that for me, and copying the code, pasting it to Xcode, trying to compile, it wouldn't work. So I was like copying the errors, pasting the errors back to the chat, and I was just like going back and forth many times. Actually, lots of times. And this is how my version controlled looked before Piotrek told me to use GitHub. Like, I'm like feel free to laugh. I know it's funny and it was very painful. And this is actually probably half of the actual projects that I had. But yeah, I was just copying the project. Just when I wanted to save something, or I was afraid that I'm just gonna fuck up everything again, I would just open the project I copied and would iterate. And actually, I was surprised that I thought I would delete the older versions, but I just typed 4C, like the name of the small sensor project. Found this like, oh my god, it's insane. But yeah, I think that tells the entire story, right? So yeah, actually, the hardware at the beginning was the hard part, because turns out that I had the prototype with a single sensor, worked perfectly, no problem. I could stream the data. I could have focused on what's happening in the actual app, like building the mobile app and starting to focus there. But I wanted to build the force plates. Like that was my goal, which is basically 8 load cells covered by force plates with some electronics underneath, right? But we really couldn't make this happen for some reason that I am not sure I understand, to be honest. But we figured out at the end that some of our hardware parts and modules were not compatible with each other. But it took a lot of iterations kind of to get, actually right now we have already a designed PCB that is working nicely, but it took really many months of iteration of prototyping to make it work. But actually, yeah, but actually, in order to get there, like I would experiment with computer vision, with inertial measurement units, with other sensors, just making a lot of mess and trying to see what sticks. You know, you make a lot of mess, you make a lot of mess, you make a lot of mess, you make as many mistakes as possible. Basically, this is my approach. Probably it's great if you know what you're doing, but I didn't have that privilege or that knowledge, so I would just make a lot of mistakes and a lot of mess, lots of trying different tech stacks, and trying to see what sticks. And from that pieces that stick, that work, I'll try to understand them and actually build something. So actually, one of the things that we built and that's working really well is it's an iOS app. Now I also ported it to Flutter just to make it cross-platform. We built jump height measurement and actually a camera app that is taking a video and is estimating these ground reaction forces from a video, from using a pose estimation model. And we ran a validation study with a professor from Kingston University. And it turns out that, yeah, it's pretty good. The orange line is from the recent Rust port shows with the really it shows a comparison with the laboratory grade force plate data. It's kind of similar, right? It's not perfect. It's far from perfect, but we are able to achieve absolute mean error of 1.4 centimeters. Which is a great result, and I will be actually writing a dissertation on this topic and open sourcing the code base. So this was one of the things that sticked, and it actually worked. Also, obviously, it wasn't. It was very. I was very focused to do this. It wasn't an accident. But yeah, back to the force plates. Just to give you a bit of a story and also like the tech stack that I'm using right now that sticked. Wait a second, the chart is not rendering. Oh no! Oh yeah, perfect. Okay. No idea. Like I'm not gonna pretend that I understand what was there. So yeah, just to kind of give you an overview of the technology right now. That we are using. Basically, it's nice. It's so nice. I can like walk and show you. We have 8 load cells that are outputting analog microvolt signals through the analog to digital converter at 1000 hertz, and we are pocketing these samples and sending them through Bluetooth to the mobile app, and then we have some basic authentication stuff there. So yeah, just to kind of show you what's happening, just a very, very broad picture, because like this is also, I think it's quite interesting that, you know, like this is like when I'm also building software using agents, I try to have a really clear understanding of what the end goal is and what are the key architectural choices or components that need to be in place in order for this to work. So just also giving you a high-level overview of that. So let's say we do a start, counter, movement, jump. We have a session start, and there's a simple Bluetooth command that is being sent to the force plates. So they start streaming the actual data. The app gets notified, and and the data is being streamed. And then we have a loop. We have a rendering loop where a Dart, we have a Rust backend and Flutter and the Dart frontend. And Dart is polling at 30 hertz and is rendering the live force rates, but it's just a rendering loop. So yeah, everything is being polled from Rust, and after the test complete, actually the entire snapshot of the event that we want to measure is then processed offline in the Rust processor, right? So we are not really actually processing the data in real time. We are actually moving the data that we captured to an offline processor, and obviously it takes very little time in order to get the results. But everything is happening in the background, and then the metrics are being pushed through JSON to the render review screen, and then the saving, let's say, and storing the data happens. So actually, I was experimenting like for a long time. I was building in Swift and building for macOS and iOS, and it worked pretty great. But like always, I had a feeling that what if Apple decides that I don't know, that I'm not good enough or something, you know, that I can't publish the app. Like I had a very horrible experience in getting an Apple developer account. Which is not really, well, I'm not really sure why, but that's fine. But then we were trying to publish an app for our beta testers, and we were waiting like 10 or 12 days for the review. And just after, I think, 6 days, I thought like, okay, I'm just gonna port everything to Flutter. And it took obviously more than 6 days, but we did it. And currently the architecture is that all the Rust owns all the logic, Bluetooth input, output, the signal processing. So every filter that we use, so for example, like a Butterworth filter, which is like a very common biomechanics filter, is also rewritten to Rust. This is like a great application for AI agents, where you ask it to optimize the signal processing algorithm to match the SciPy, the Python reference. It's kind of very clear for the agent what's the verification, what's the outcome, right? It needs to match the output of the reference filtering. All the phase detection, so how we slice the data, how we detect states, how we detect when the movement happened, it's everything. And the metric computation is in Rust. And the Flutter Dart handles UI, charts, navigation, Riverport, the local SQLite, and the Cloud Sync. We have I'm collaborating with one software developer right now that handled the Cloud Sync infrastructure. And we have a nice simple solution there, where we basically use the cloud as a relay to move the data between the devices, but not necessarily to store the data online. And actually, like after 1.5 years of work, we are able to, again, you know, because we're building a measurement device, and you know, like you go to a shop and you buy a ruler, right? Sorry, I'm just laughing at my own jokes too hard. But you go to a shop and you buy a ruler, like you expect it to measure the same, right? Like you expect the measurement to be the same. So building this sort of technology that needs to be precise, you need to actually know how precise it is in order to provide accurate data. And we run a comparison analysis across, I think the entire validation study was around 500 metrics. And we found out that on the most relevant ones, we had a really high correlation, like almost basically matching the gold standard in the industry. So just to wrap this up, I think I'm perfect with time. Just like a couple of lessons and opinions that I have, and hopefully you'll have some also comments or questions, and we can discuss this more. I think that, like, I think it's quite difficult to question right now that that the actual act of writing code cannot be done by large language models. I think probably already most of the people here, like this is my hypothesis, maybe I am wrong, but I would expect that like we would agree that yes, like large language models are pretty okay, pretty good at writing code. They need to be led, they need to be constrained, they need to be harnessed, right? But like maybe it's not done, but it's getting there, right? So I think it's so much more relevant to actually become an expert at describing what you want. how easy and dumb that sounds. It's not that easy to know what you want, right? If you know what you want, maybe it's easy to describe. But how do you know what do you want? Right? Like how do you know what you want? How do you know what is relevant for you to build? Maybe if somebody tells you what you want or should build, then you can transform that into actual text and later code. But this is like an amazing capacity that we have right now to influence software, to influence the digital world, right? And I think it's like amazing, and I think it's really important to think, what do we want to do with that? You know, do we want to, I don't know, do like Meta did with the AI generated videos, right? For just driving the engagement, like some sort of like a slop, or do we want to somehow, I don't know, do something that's meaningful, important, helpful, that is reducing human suffering? I think, for me personally, opinion, this is really important at the moment. Somehow related, but but no amount of prompting can replace your capacity to self-reflect. Why are you laughing?
I didn't come here for a life lesson.
Sorry. Yeah. I mean, this is how I code. You know, I take it seriously. So no, but what I mean with this is, it's like, huh?
What do you mean?
You know, like, I think that it's the same idea that I described before, maybe in other words. But it's like so easy to overview the output, right? You're constantly like think about how much information the LLMs can provide you. Like you're just being constantly fed with information. Like you're running 10 agents, right, in your terminal, and you get constant information. Like, how often do you feel, because I feel it almost every day, that I'm just like, there's just way too much going on, and I'm starting to lose the sense of what I'm building, or like what was the whole idea of this. There's just way too much. So in the same way as your agents, you know, maybe you have a agents.md file or claude.md file, and you're kind of putting there the things that they want to remember. I think that the same way should apply to how like we approach ourselves, you know, and then it's easier to manage those agents, to navigate those agents. Because if you don't know again what you want, then it's difficult to describe. Yeah, another of my opinions. Because I had a meeting with a marketing agency team, and they're looking. I was showing the product, and they were like, yeah, and then you can have a virtual reality where you have a virtual coach, so you don't need to talk to other humans, and we don't need coaches anymore. Okay, fine. Probably, I personally, again, I wouldn't like that. So what I'm thinking about is, again, how I can use this software and this tool and this power is how can I build technology that will support these specialists. Something that is important for me. Personally, I definitely felt over the 18 months like the fatigue of working with AI and with how addicting it is and how 100x human you can feel, right? When you're like managing the 15 agents and one of your agents is managing 20 agents and so on. But I think it's not worth it when you start to sacrifice your health and your well-being. I think it's again important to reflect on like why. Like if I make a new unicorn, right? If it's actually worth it was worth losing your health, losing your capacity to, I don't know, move around and just enjoying other things in life. Actually, I was really not, I had no idea that it's gonna be that it's gonna feel so deep. Like I was not intending that. Like I was really not intending that. So I apologize if that's not the, that's kind of breaking the expectations of the event. But yeah, like that wasn't the plan. But that's fine. That's it. Thank you so much. Questions, comments?
Thank you. That's great presentation. Maybe answering the question on how to like what I want, yeah? Maybe the feeling of aesthetic.
The feeling of aesthetic.
Yeah, that's what helps. Yeah, but the question is like having a lot of these measurement devices, like the personal devices especially. What do you think about like the idea or possible future where like everyone has a personal AI agent that consumes all this data gathered from the personal devices and like even some, I don't know, personal advices or...
Yeah, I think it's a wonderful idea. And I think that I hope that it will be developed. Hopefully it would be great if those model that would process this data would be able to run locally. That would just definitely, like for me personally, also it would feel like I would feel better to use that. But that's I think that's quite challenging because the interpretation layer is very difficult, and one signal or event can mean different things in different individuals. So actually the fusion of the sensor data, it's something, it's like a part of the field that definitely needs to be developed, and we are not there yet. Although maybe some people would say that we are there, I disagree. Because most of the, for example, prediction models for certain, to speak about sport, like actually force plates were used in US military, and they were trying to predict injuries from the force plate data, and it actually didn't work. And there was the entire company that was kind of built on that premise that they would predict injuries or overuse injuries that before they happen. It didn't work, and it turns out that it's a little bit more difficult than we think. But yeah, I think that's a good idea.
Does your force plate support like left, right leg?
Mm-hmm. Yes.
Okay, that's actually I thought when you mentioned the injury prevention.
Yes.
Okay.
Yeah. Yes.
All right, I'm gonna count it as a one and a half questions. So, okay, I'm gonna pick you, all right, and you can ask a question.
Hello. What's your final plan for these devices or this idea? Do you want to sell thousands or millions of that, or do you open your own gym or what?
Yeah. That's great question. Yeah, so actually, right now we are focusing on sport performance market. So professional and semi-professional sport teams and people that participate in different sport disciplines that want to improve their performance. So this is like our first target group. This is definitely not like a huge market, right? This is not like huge market, but we are starting there. This is something that also matters for me personally, because I work with people and I work with kids, and I want to see them thriving, and I want to see them improving, and this is what's also driving, it's giving me motivation. So we are focusing on this right now. There is potential to work in general with human performance data, and processing that data in order to improve the decision making for now it's coaches, but later maybe it's service members, like also the military, maybe it's healthcare, right? But in general, in the future, or like my aspiration is to build a system, or to build a monument. I like this. I heard it from DHH. It was saying like calling a code base a monument, right? To build a monument that is able to process data from different sources and provide insights that support decision makers.
If you have any other question, I'm sorry, but you're gonna have to wait for them, for Filip on a break. And right now, let's give another big and yeah, you know the drill.